Good morning, Math 20-1. Lesson 6 in the trig chapter is the cosine law. So we start off with a warm-up question. Consider the following triangle. Angle A is 36 degrees, side length AB is 3 centimeters, and side AC is 6 centimeters. Determine the length of BC. So press pause, take a moment, and try to find out BC. What you should have noticed is if I set up my sine ratios, I've got side A is to the sine of 36 degrees, as side B, which is 6 centimeters, is to sine of angle B, as side C, which is 3 centimeters, is to sine C. We have a problem. We don't have enough information. So I'm missing. I don't have a complete set here. I need to have a complete set in order to use the sine law. So I can't use this. I need something else. So let's take that same triangle. Use SOHCAHTOA in the diagram below to determine the length of BC to the nearest tenth of a centimeter. So again, press pause and try to determine the length of BC. So how would we go about this? Well, if I could somehow figure out this stuff in this triangle, I could have a shot. So what can I do? Well, I have triangle ADC. I could find out AD. Then maybe I could find out some more information. So let's try to find out CD. Sorry, not AD, CD. So let's try to find out the length of CD. I have an angle, its opposite side, and the hypotenuse. So that's sine. Sine of a 36-degree angle equals side length CD over 6. To get CD by itself, I multiply both sides by 6, and I get that the length of CD is 3.5267, and it goes on. That's CD. Now, maybe I could find out the length of A to D, this one right here. Because if I have the angle and its hypotenuse, this is the adjacent side, so I can use cos. Cos of a 36-degree angle is the adjacent side, AD, over 6. So to get AD by itself, I get 6 times cos 36, which gives me 4.8541 on and on. If I know the length from A to D, I can figure out B to D by taking 3 off of this. 4.8541 minus 3, and I get 1.8541 meters. So now if I label this triangle, I have this measurement, that's my 3.5267. This measurement's 1.8571. And I can now find CB, or BC, using Pythagoras' theorem. 1.8541 squared plus 4.8541 squared would equal BC squared. So then BC would be the square root of that answer, which is 15.8753. So 15.8753. And the square root of that gives me, to round it to the nearest tenth, 4.0 centimeters. I guess this right here should have been centimeters as well. That is a lot of work to do this question. A lot of steps. And again, in math, we're always looking for patterns. We're always looking at, is there another way that I could do this? And maybe you came up with another way when you were doing this on your own. But there is another way where I don't have to revert back to SOHCAHTOA. And that's the cosine law. The cosine law says in every triangle ABC, there exists the following relationship. A squared equals B squared plus C squared minus 2BC cos A, where A, B, and C are the sides of the triangle, and capital A, capital B, capital C would be the vertices. So again, we start off with a proof. This diagram shows triangle ABC placed with AB on the x-axis and A is at the origin. The line CD is drawn so it's perpendicular to my base and it has a length of h units. If I say that A to D is x, D to B would be C minus x units. C, because this whole length here from A to B is across from angle C, so it would be side C. So if this is x units, this would be the remaining when I subtract it from C. So in triangle BDC, that's this triangle right here, I have Pythagoras theorem. BC squared plus CD squared, BC squared equals CD squared plus BD squared. And then if I substitute in the letters, BC is side A, CD is side H, and DB is C minus X. When I go to expand this out, C minus X squared, when I FOIL it, I get C squared minus 2CX plus X squared. Because remember, it's C minus X times C minus X. If I collect my H and my X's, and then I leave this over here, H squared plus X squared, if I get into this triangle right here, what is X squared plus H squared? It's B squared. And then right here, this X, we have to do a little bit more work in here. We have to go back to this side. So we'll stop at this point, and now we'll go over to this side. In triangle ADC, right here, I have cos of angle A equals the adjacent over the hypotenuse, x over b. So if I want to get x by itself, I get rid of this b value by multiplication. And I get that x equals b cos A. That's what x was right here. B cos A. And there's my proof for the cosine law. Now, if I change this triangle around and I put BC on the x-axis and then I put AC on the x-axis, I get two other formulas. B squared equals C squared plus A squared minus 2CA cos B. And C squared equals A squared plus B squared minus 2AB cos C. Look at these values. The side that I'm trying to find is opposite the angle that I'm given. And then I have the other two side lengths. So the cosine law works when I have side, angle, side. When I have any two sides and the contained angle, so the angle that comes between the two sides. That's when I can use the cosine law. So let's look at the first class example. Again. So I'm trying to find this side length, side A. So my formula would be A squared equals B squared plus C squared minus 2BC cos A. Remember, the side and the angle have this relationship. So I have B squared, or side B, is 6. So we have 6 squared plus 3 squared minus 2 times 6 times 3 times cos 36. So I put all of that into my calculator. And my calculator gives me a value of 15.8753, which is actually the same thing that we got last time. And then we take the square root of it. So we take the square root of that answer, and I still get 4.0 centimeters rounded to the nearest tenth. Next example. Press pause and try this example on your own. So the biggest issue that comes with this example is it no longer has A's and B's and C's. So how would I do this? Well, let's start labeling it off. QP, that's this length here, is 1.7. That's also side R. QR is 3.1, which is side P. And angle PQR is 110 degrees. So what am I looking for? I'm looking for side Q. So I get Q squared equals these two sides squared, or the sum of those two sides squared. So P squared plus R squared minus 2 times P times R. And then my cos is Q, because this is what has to match up. So I put in my values, and I get 3.1 squared plus 1.7 squared minus 2 times 3.1 times 1.7 times cos 110 degrees. My calculator gives me this value of 16.104 on and on. So then Q would be the square root of this value, which to the nearest tenth of a centimeter would be 4.0 centimeters again. Class example number 4. Bellevue is 30 kilometers north of Ayr, and Churchville is 18 kilometers northwest of Ayr. Calculate the distance between Bellevue and Churchville to the nearest kilometer. So let's start off with Ayr, because Bellevue and Churchville are both given in terms of Ayr. So Bellevue's 30 kilometers north. That's straight up. 30 kilometers. So here is Bellevue. Churchville is 18 kilometers northwest. So northwest, if this is Ayr, north, east, south, west. Northwest is halfway in between. So here's Churchville, 18 kilometers away. So there's Churchville. The question asks, calculate the distance between these two, Churchville and Bellevue. So I have two side lengths, and right now I don't have an angle indicated. Can I figure an angle out? I can, right here. This northwest. Northwest means halfway between north and west. Between north and west is 90 degrees. Halfway in between would be 45 degrees. Now I have two sides and the contained angle. I'm trying to find the distance across, which in this case happens to be a small a. So I have a squared will equal b squared plus c squared minus 2bc cos a. Again, there's my match. So b squared would be 18 squared plus 30 squared minus 2 times 18 times 30 times cos 45. When I put that into the calculator, I get 460.32. And when I take the square root of that number, I get 21.45, on and on. So to the nearest kilometer, this would be 21 kilometers. So what I want to do is I want to and do the next the next two class examples, and then I'll give you all of the questions for this section. When I look at this formula works when I have two sides in the contained angle. But could I use this formula for all three sides? Yes, I could, because I can rearrange this formula. I can take this formula and isolate cos A. To isolate cos A, what I would do is, this is a negative on this side of the equation, so I would actually move it to the other side of the equation. So I would move this negative term to the other side to make it positive. Then I would move this a squared over. So I'd have 2bc cos A equals b squared plus c squared minus a squared. And then to get cos A by itself, I would divide by 2bc. So things to note in this equation. The b and the c are still being added. I divide by the 2bc, and I subtract by the a squared. So it shouldn't matter what the letters are. You should still be able to transpose them into the questions. So if I wanted to find out cos B, so the thing to remember with cos B is my equation would have been b squared equals a squared plus c squared minus 2ac cos B. And that was a couple of pages ago. If I want to get cos B by itself, it's still going to be a squared plus c squared. Now I'm going to subtract the b squared, and I'll divide by 2ac. If I want cos C by itself, I will add a and b. I will subtract the c, and I will divide by 2ab. Your formula sheet gives you these two equations. These ones you're expected to be able to derive just from the links between the a's and the b's and the c's and the cos A's and looking for patterns. So let's look at class example number 6. Determine the largest angle in triangle ABC if I have the following side measurements. So let's draw a triangle ABC. So there are 3 different side lengths. So this looks to be my longest side, so I'm going to make it 14.7. That'll be angle A. This side length here looks to be the next largest. That will make it 12.6, which means this will be angle C. And then 8.9 is my shortest, which means this is angle B. Now in this question, you're asked to find out the length of the largest angle, but you're not told which is the largest angle. Think of a right triangle. In a right triangle, the 90-degree angle is always the largest angle. And what is it always across from? The hypotenuse. And what is the hypotenuse? It's the longest side. So the longest side will be opposite the largest angle. So I am being asked to calculate angle A. So cos A will equal b squared plus c squared minus a squared divided by 2bc. So that will be 8.9 squared plus 14.7 squared, or sorry, not plus 4, plus 12.6 squared minus 14.7 squared divided by 2 times 8.9 times 12.6. When you go to put this into your calculator, use brackets. Open, close, open, close. That will tell the calculator to do the top, do the bottom, and then divide the two answers. When I do this, I get an answer of 0.0975. Again, 0.0975 on and on. That's the cos of the angle. To find out the actual angle, I have to go cos inverse of that answer. And that gives me 84 degrees. So if you want right now, try pausing and take a look at class example number 7 and see if you can get this one. So let's begin. Two ships set sail from a port which we'll label P, heading in two different directions. The first ship sails 7 kilometers to point R, and the second ship sails 8 kilometers to point Q. If the distance between R and Q is 13 kilometers, determine the angle between the directions of the two ships. That would be angle P. So in terms of my cosine formula, that would be figuring out what cos P is. So cos P would be, so here's P, R, and Q. It's going to end up being Q squared plus R squared minus P squared divided by 2QR. So that will be 7 squared plus 8 squared minus 13 squared divided by 2 times 7 times 8. Remember my brackets. Now, I should know whether or not I've done this correctly simply by the fact that cos has to be less than 1. So it has to be a decimal, 0 point something. Or it could be a negative 0 point something. In this case, it was negative 0.5. So then to figure out angle B, I cos inverse that. Now, when I go to cos inverse that, I want to cos inverse this with a positive 0.5, which is going to give me 60 degrees. This is no longer angle P. This is now the reference angle. So if my reference angle is 60 degrees, angle P has to be obtuse because it's opposite the longest side, which means it's going to have to be a larger angle. So it has to be obtuse. So it has to be 180 minus the 60. And it has to be 120 degrees. If you go cos inverse negative 0.5, you do get 120 degrees. And that's because we are in quadrant 2. And so your calculator will give you the first angle, but it won't give you the second. So it would give you the 120 degrees, but it wouldn't actually give you what would end up being the 240 degrees, which is what that angle would be in the third quadrant. It's a discussion to have tomorrow. So your questions that I want you to work on are questions 4, 5, and 8, 10, 11, and 12.